Good morning, my dear students. My name is Anjali Sharma, working as physics lecturer in one of the reputed institution. Today we are going to know numerical part of physics. So very important for all competitive exams. That is based on this differentiation, integration, dot product, cross product, graphical part. So based on all this, definitely you will be given 3-4 questions. No? So first we'll discuss about differentiation. So in this problem, you have given angular displacement. So angular displacement of the body is given as t cube plus t square plus t plus 1. So you want to find angular velocity. You have given angular displacement, you want to find angular velocity. How? By differentiating this function with respect to t, we get angular velocity. 3t square. Differential value of t cube is n into x power n minus 1 na? So that is why 3 into t power 3 minus 1. So 2 into t power 2 minus 1. And differential value of t, 1, and any constant 0. So you get angular velocity omega is equal to 3t square plus 2t plus 1. You want at 2 seconds. So put t 2 seconds. So 12 plus 4 plus 1. 17 units. That is, radian per second. Now about the given problem. You have given flux linked to a coil. Flux given as 10 t square minus 50 t plus 250. So you want to find induced EMF at t equal to 3 seconds. So induced EMF is always equal to rate of change of flux with opposite sign. So whenever this is differentiated now, you get EMF. So differentiating this function with respect to t. So d phi by dt. So 10 into t square differentiation 2t na minus 50 into differential value of t 1 na. Next any constant 0, right? So you get minus, this is with minus sign na, so minus 20t plus 50. You want at 3 seconds, so put t 3 seconds. So it is minus 20 into 3, 16 plus 50, nothing but minus 10 volt. Units of EMF volt na. So flux differentiating with respect to time, you get EMF. So this is the formula we are using. Now the displacement of a body you have given, they are asking us to find velocity after 2 seconds. So whenever you differentiate displacement na with respect to time, you get velocity. So differentiating displacement with respect to time. 4 into differential value of t 1 na minus t square 2t, right, plus 3 into t cube 3t square na minus 4t cube. Okay, so you want to find at t equal to 2 seconds, right? So 4 minus 10 into 2 na plus 9 into 2 square minus 4 into 2 cube. Okay, so 4 minus 20, okay, 36, 32. Now, so 36 minus 32, plus 4, 8 minus 20. So nothing but minus 12. No, units meter per second. Now, the given problem is momentum of a body is given as alpha plus beta t square. Okay, so you want to find a force. So remember, whenever you differentiate momentum with respect to time, you get force, means dp by dt. Okay, so whenever you are differentiating this equation, okay, with respect to time, so dp by dt is equal to differential value of constant 0 plus beta into 2t. Okay, so this is the force on the body, nothing but 2 beta t. Now, momentum of a body in x direction and y directions you have given, so you want to find force. So, momentum of the body in x direction given as 2t square plus 6. Okay, so whenever you differentiate with respect to time, you get force in x direction. Okay, so 2 into differential value of t square 2t plus constant 0. So force along x direction 4t. You want after 2 seconds so substitute. Okay, so this is in x direction. Similarly, you can find in y direction also that is momentum given as 3t square by 2 plus 3. Okay, so when you differentiate this equation with respect to time, you get force, right? So 3 by 2 into t square differential value 2t, right? Plus constant 0. Okay, 2 cancel 3t. You are finding force after 2 seconds now. So 3 into 2, 6 units. So force along x direction plus along y direction. So it is 8 units, another one 6 units. Therefore, the magnitude of force will become 8 square plus 6 square. So 10 units. Okay. Now, potential function you have given, we want to find electric field. Okay, so electric field strength is equal to minus dV by dr. Okay, so potential differentiated with respect to r, you get electric field strength. So potential function we have given. So whenever you are differentiating partially with respect to x you get Ex. Okay, dou v by dou x. Okay, so this is the given function So minus of, okay, so minus x square differentiation, 2x and y taken as it is, just like constant, because you are differentiating partially with respect to x, right? So minus x z square, okay, plus constant 0, right? So it is nothing but you can say 2xy, okay, plus z square. So this is about Ex. Similarly, we can find Ey also. Minus dou v by dou y partially with respect to y. Okay, minus of, right? So minus x square as is now differential value of y 1, right? Minus 0 because you are differentiating with respect to y now, so that is why the other treated as constants. Okay. Next, dou v by dou y completed. Now dou v by dou z minus of. Now you are differentiating partially with respect to z now. So this part is 0, right? Minus x into z square differentiation 2z now plus constant 0, right? So you get minus of minus plus 2x z. Okay, therefore electric field strength E becomes, right? You get Ex means 2xy plus z square na into I plus second one x square into j, last one 2xz into k. Okay, so this is the strength of electric field. Okay, now based on integration also we'll do some problems. So whenever momentum is differentiated with respect to time, you get force, right? So change of momentum is also called impulse, right? So dp is equal to f dt. So whenever you integrate on both the sides, you get impulse. So integral form of impulse is integral f dt. So you want to find impulse for first 4 seconds. Okay, so limits taken 0 to 4. F, according to problem, it is 10 plus 2t, right? dt. Okay, so it is 10 dt plus 2t dt. Between the limits 0 to 4. Okay? So 10 dt integral t na, between the limits 0 to 4 plus 2 integral value of t. So whenever x power n dx, you are taking x power n dx integral value x to the power of n plus 1 by n plus 1 na. So here power is 1, right? So you get 1 plus 1, 2 by 2. Between the limits 0 to 4, 2 to cancelled. Okay, always upper limit minus lower limit na. 4 minus 0, right? Plus 4 square, no, minus 0. So 40 plus 16, 56. Okay, force into time na, so Newton second. Now about the given problem. So dv by dt, rate of change of velocity, okay, is given as minus 2.5 root v. Okay, so they said in the beginning the particle is moving with 6.25 meter per second and decelerated. Okay, so you want to know the time taken by the particle to decelerate. Okay, so if you bring all variables one side, okay, dv by root v equal to minus 2.5 dt na, so integrate, okay, between the limits 6.25 to 0, because they said the particle in the beginning is moving with 6.25 meters per second and decelerated, no, so 0 velocity. Okay, now about integration of dv by root v, so you can also take this to numerator na, between the limits 6.25 to 0, okay, so minus 2.5 dt is t na. Next, so integral part of minus half, you know, whenever it is x power n na, you are writing x power n plus 1 by n plus 1. Here n is taken as minus half na, so minus half plus 1 by, you know, minus half plus 1. Okay, half by half, nothing but, you know, 2 root v, right? So 2 root v na, limits 6.25 to 0, right? Minus 2.5 t. Okay, so you can take first upper limit, then lower limit, right? So you know, after simplifying, that is, you know, 2 into minus of 6.25 na, root, minus minus cancel now, into t. Okay, so when you further simplify na, cancel, you get t equal to 2 seconds. Okay, a graph is plotted taking time along x-axis, okay, velocity along y-axis. So you want to find the position of the particle, nothing but you can say displacement. After how many seconds? 5 seconds. Okay, so you know, area of velocity versus time graph gives displacement, nothing but you can say position of particle, but you want up to 5 seconds only, so you need not consider the total area up to 8 seconds. No, you want its position only after 5 seconds. Okay, so this shaded portion is only we require, right? So first one is a triangle now, and moreover all are on positive side, so they must be added now. So triangle, half base into height, base to height is also 2, okay, plus 2 to 4, difference 2 na, this is also 2, nothing but you can say it is a square, no, plus 4 to 5, 1 na, difference 3, okay, so cancel now, 2 plus 4 plus 3, 9 units, nothing but you can say 9 meters, means its displacement after 5 seconds becomes 9 meters. Okay. Now about the given problem. So there is 1 kg mass body. Okay. So there is 1 kg mass body. On it some force is acting. So that force is changing with respect to time. Okay. So you want to know work done in first 1 second. Okay. So you know work done is always equal to change in kinetic energy. So kinetic energy you can also find through momentum. No? So kinetic energy is equal to P square by 2m now. So change of kinetic energy is equal to change of momentum square by 2m. That means it's very clear that if you know momentum followed by you can find energy and you can find work done. Right? Now, so force is equal to 6t, right? So differentiating momentum you get force, right? Or dp is equal to 60 dt, right? Integrate it on both the sides. Then change of momentum, right, is equal to 60 dt. So you want to find the work done from 0 to 1 second. No? So limits are 0 to 1. Okay? So integral t, t square by 2 na, limits 0 to 1, right? 2 divides 6 3 times, right? So momentum is equal to, okay, 1 square minus 0 square. So 3 kg meter per second. No, so that is momentum. So it is nothing but change of momentum. So change of kinetic energy also you can find now. That is kinetic energy is equal to P square by 2m. No, so 3 whole square by 2 into mass of the body. Here mass of the body is 1 kg now. So that is why 9 by 2. Nothing but 4.5 joule. So work done is equal to change in kinetic energy now. So work done during first second is 4.5 joule. Okay. Now in this problem, force function you have given, that is 2xi, okay, plus 2j plus 3z square. Okay, so you want to find work done between these 2 points. So small work done is force into displacement, or you can take work done as F dot dr. No? So F bar into dr means you can write dxi plus dyj plus dzk, right? So when you are integrating it on both the sides now, you get total work done. So 2x dx dot product a1 a2 plus b1 b2 plus c1 c2. No? So that is why integral, okay, 2x dx limits, x is moving from 1 to 3. No? So lower limit 1, upper limit 3. Okay? Plus second one, 2dy. Y limits, 2 to 6. Plus next one 3z square now, so integral 3z square dz. Okay, limits 3 to 1. Okay, so this is equal to 2 into integral x dx, x square by 2 now, limits 1 to 3. Okay, plus 2 as it is, integral dy is y now, between the limits 2 to 6, plus 3 now z square, integral value z cube by 3 now, between the limits 3 to 1. Okay, 3 cancelled, here 2 cancelled. Okay. So we can find work done. So integral dw is w na. So w is equal to, okay, 3 square minus 1 square. You know, always upper limit minus lower limit, plus 2 of upper minus lower. So 6 minus 2, plus, you know, z cube, right? So 1 cube minus 3 cube. Okay? So you know, 9 minus 1, 8, plus 4 into 2, 8, right? Plus 1 minus 27. No, 16 plus 1, 17. 17 minus 27, you know, minus 10 units is work done. Okay? Now in this problem, there is one rubber band of length L. So work done in stretching. So you know, when you apply some force on it, it will deform. Due to its restoring force, you know, it will get back to its original position. So you can say the internal energy must be equal to work done. No? So work done is equal to, you know, force into displacement. No? So when you are integrating now between 0 to L, you get total work done, which is equal to, you can say, energy, right? So yeah, it is ax plus bx square, right, into dx between the limits 0 to L, right? So while integrating, you know, always the constants will take out of integration. Power 1 dx, right, between the limits 0 to L, plus b of x square dx na between the limits 0 to L. So a of x integration value, you know, x square by 2 between the limits 0 to L, plus b x square integration, you know, x cube by 3 na between the limits 0 to L. Okay, therefore when you substitute na upper minus lower, you get total work done. No? So therefore total work done is equal to, right, a by 2 of upper limit minus lower limit na, so only L square, right, plus b by 3 of L cube. Okay, so this is the work done. Now about the given problem. Okay, force taken along y-axis and time taken along x-axis. Okay, so a graph is plotted between force and time. So you want to find change in momentum. Okay, so you know, momentum is a vector quantity. So you know, the area of this product, force into time, gives, you know, change in momentum, or it is also called impulse. No, great force is acted within short interval of time. So it is very clear that area of this graph is equivalent to impulse. By taking the areas, you know, which are on negative side must be subtracted. That is, if it is a vector quantity. Otherwise you have to add all areas. So you know, change in momentum or impulse is a vector quantity. So that is why this area must be subtracted. This is added because you know it is on positive side of x-axis. Okay, so it is length to breadth to, no, square form, minus 2 into 2, right, area of this. So you know this is equivalent to area now. So remember, area of force versus time graph gives impulse. Okay, so 2 into 2 minus plus. Why plus? Because it is on positive side. 2 to 6 now, so difference is 4, right, into 1. No? So plus 4 minus 4 cancelled, 0. Therefore impulse is 0. Okay? A graph is plotted taking time along x-axis, okay, velocity along y-axis. So you want to find the position of the particle, nothing but you can say displacement. After how many seconds? 5 seconds. Okay, so you know area of velocity versus time graph gives displacement, nothing but you can say position of particle, but you want up to 5 seconds only, so you need not consider the total area up to 8 seconds. No, you want its position only after 5 seconds. Okay, so this shaded portion is only we require, right? So first one is a triangle now, and moreover all are on positive side, so they must be added. No, so triangle half base into height, base to height is also 2, okay, plus 2 to 4 difference 2 na, this is also 2, nothing but you can say it is a square. No, plus 4 to 5 1 na, difference 3, okay, so cancel now, 2 plus 4 plus 3, 9 units, nothing but you can say 9 meters, means its displacement after 5 seconds becomes 9 meters. Okay. Now based on this cross product also you will be given definitely one question. Okay. So how to find cross product of two vectors? See, when you are taking two vectors, okay, so the two vectors are containing on this plane, so the resultant is moving in upward direction like this. Suppose you are taking the cross product of two vectors, the resultant is in upward direction. Okay, so in physics we solve many problems based on cross product also. So in this problem you have given about force and also position vector. You want to find torque. Okay, so you know torque is a cross product of position vector and force. Okay, so cross product will always gives us a vector quantity. Now we are going to know how to find cross product of two vectors. Very simple. You draw one box. First row you write I, J, K. So you want to find R cross F now. First you take R. So 3I plus 2J. So I quotient 3 na, 2J 2. No K term no. So take 0. Okay. Next F. I quotient 2 minus 3. There is no K term, that is why it is 0. No, I off. So whenever you are going to find I quotient, you close I column. Okay, J quotient, close J column. K quotient, close K column. So first I quotient you have to find na, close I. Right minus left. Anyhow 0 na. Minus J off, you know, right minus left 0, okay, plus K off, K, no, right minus left, minus 3 na, minus 4, always right side product minus left side product, so nothing but you know minus 13K. Okay. Now in this problem, the adjacent sides of parallelogram you have given, you want to find its area. So you know, area of parallelogram is equal to mod of A bar cross B bar, means the cross product of adjacent sides. So So here you have given P and Q now. So take P bar and Q bar. Okay. You know how to find cross product. Right. In the first row you write I, J, K. Next first vector. Now 3, 4. K term 0. Right. Next minus 5. Okay. 7. K term 0. Right. So first you have to find I quotient now. So whenever you want to find I, close I column. Right minus left 0. J always taken negative, remember. Okay. Again right minus left 0 plus K off. So K you are considering now. So close K column 21. Okay. Minus 20. Minus of minus plus 20 now. So you get 41K. Its magnitude you want to find, right? Mod. So root 41 whole square, nothing but you can say 41 square units. Okay? Now about the given problem. There is one alpha particle. Okay? So this alpha particle is held in a magnetic field. Alpha means charge particle now held in magnetic field. So it will experience some force. No? So whenever you place a charge particle in the magnetic field, it will experience a force, that is F equal to Q of V bar cross B bar. No? So this is the force. Alpha particle having 2 units charge, 4 units mass now. So V bar cross B bar. Charge of alpha particle. 2 units charge. No? So 2 into charge on electron 1.6 into 10 power minus 19 coulomb. Right? Now this cross product. So how to find the cross product of 2 vectors. No? I, J, K. Right? First you are taking V. Right? So 5 into 10 power 5. That is I quotient now. Cross B. So 3, 2, 0. Right? So how to find cross product. When you are taking I, I column must be closed. 0. Right? Minus J of 0 plus K of 10 into 10 power 5 now. That is about K. So you can write 10 into 10 power 5. Okay? In K direction. Okay. So 3.2. Okay. So 10 power 6 na. Units of force. Newton. Okay. So this is the force gained by alpha particle when held in the magnetic field. Now we are going to know about dot product of 2 vectors. So dot product is also called scalar product, right? So based on this dot product also you have given number of problems. So remember one important point under dot and cross is dot. By doing dot you get the area that covered between the 2 vectors you get. By doing cross you get the total volume you get. Okay. So cross is a vector one, dot is a scalar one. So that is why it is also called scalar product. So in physics we come across different dot products. Dot product of force and displacement gives work done. Power, force dot velocity also gives power, scalar quantity. Next, electrical flux or magnetic flux. Electrical flux is E bar dot A bar, where A is area of cross section, not area. So remember, area is scalar, area of cross section is vector. So E bar dot A bar, or else you can take B bar dot A bar. Okay, so these are all dot products. Now based on dot also we'll solve now one problem. Okay. So in this problem, you have given strength of electric field vector. Okay, so area is 100 units given in XY plane. No, so XY plane now, so its projection taken along K. So 10 units in K direction is area of cross section. Okay, so E given as 8I, okay, 4J plus 3K. Okay, it is strength of electric field and this is area. So you want to find electric flux. Now, so flux equal to E bar dot A bar. Okay, so it is in XY plane, that is why you have taken K. Suppose YZ plane, X means I should take. Okay, so E 8I, okay, plus 4J plus 3K dot 10 100 K. Okay, so how to find dot product? A1 A2, B1 B2, C1 C2. So here no I J terms now, so that is why the quotient is taken 0. So that is why A3 B3. So 300. So 300 units is flux. Okay, so in this way it is easy to solve all problems. So go through each and every problem given in this video. I hope you can easily face any competitive exam. So if you like this video, please subscribe, like and share. And in order to subscribe, so there will be one icon given at bottom. So if you press, you can subscribe my channel. Today we are going to know about important problems related to modern physics. So based upon this modern physics, in any competitive exam, you will be given mainly 4 to 5 problems, definitely. Okay, so today our first concept is about photoelectric effect. Photoelectric effect. So what is photoelectric effect? Whenever light of suitable wavelength is made to fall on alkali metals like lithium, sodium, potassium, then some part of energy is utilized by the metal to extract electrons, okay, and the remaining part of it is useful for kinetic energy. Okay, so that is H nu is equal to, okay, the given energy is utilized to metal in two ways. Certain part for extracting, this you call technically work function, okay, plus kinetic energy. It can also be taken as EV naught. So V naught is called stopping potential. Okay, so based on this photoelectric equation, today we are solving problems. So what is your given question? That is, there is one metal plate. Okay, so this metal plate is illuminated by light of wavelength given lambda. Okay, so in the beginning it is illuminated by lambda wavelength. Okay, so this is the metal wavelength lambda. So stopping potential in the first case is 3V naught. Okay, so according to Einstein's photoelectric equation, right, H nu is equal to work function plus kinetic energy, that can also be taken as EV naught, right? So in the first case, Hc by lambda also you can write now, nu can be taken as C by lambda, which is equal to work function plus first case 3V naught. Okay, now on the same metal of wavelength 2 lambda is incident. So I am taking in the second case 2 lambda. Same metal now, so no change in the work function. And stopping potential in the second case is V naught. So nothing but you can say EV naught. Okay, so equation 2, equation 1. So what we require to find under this problem, you want to find threshold wavelength, right? So what is threshold wavelength? Minimum wavelength required to produce photoelectric effect. Work function is taken as H nu naught now, that can also be taken as Hc by lambda naught, right? Pi equal to Hc by lambda naught. So in order to find lambda naught, you require work function and product of Hc. So thereby you can find lambda naught, right? So first we need to find work function and also this product Hc value, right? So now you divide this equation by 2 because you can equate now solving. It is Hc by 2 lambda. So divide this thing by 2. Okay. Okay, so you want to equate these two, so that is why you are equating. Okay, now so whenever you are equating now, Hc by 2 lambda is actually pi plus EV naught. So instead of this, you can write here pi plus EV naught. Okay, take this to other side. Okay, pi minus pi by 2, right? Equal to EV naught, if you take common now, 3 by 2 minus 1. Nothing but 1 by 2 now. So EV naught by 2. Okay, so this is when you further simplify, you get pi by 2 now. So 2 cancel, you get work function value as EV naught. Right? So work function is known to us. No? So pi can be taken as EV naught. So this I am taking now EV naught. Okay. So you want to find now wavelength. No? Threshold wavelength. Okay. So Hc value will become 4 EV naught into lambda. Okay, so Hc product and you also know work function, that is EV naught. So by knowing these two you can find threshold wavelength. Okay, so threshold wavelength lambda naught, work function is E pi equal to H nu naught. This can also be taken as Hc by lambda naught na? Hc by lambda naught. So lambda naught will become Hc by pi na? So Hc product, you got 4 EV naught lambda, okay, by pi EV naught. EV naught cancelled, you will get 4 lambda. Okay, so remember work function taken as h nu naught. Okay, that is hc by lambda naught. Okay, so for all problems you need to remember only one important point. H nu equal to pi plus EV naught, otherwise kinetic energy. Okay. Now, see, light of wavelength lambda is made to incident on a photoelectric surface in the first case. Okay, corresponding kinetic energy emitted is say Ke maximum. Okay, in the second case, it is emitted with lambda by 2. And corresponding kinetic energy is 3 times of initial one they are saying. Okay, so you want to find the work function. Okay, so you know, according to Einstein's photoelectric equation, so light energy given to the metal is always utilized in 2 ways. Certain part extracting electrons and remaining part is kinetic, right? So Ke maxima. So here instead of frequency you have given wavelength na, so that is why it must be converted. Hc by lambda, okay, is equal to work function plus Ke maxima. Okay, therefore kinetic maximum in this case becomes, you know, hc by lambda minus work function, say equation 1. Now in the second case they are saying kinetic energy is 3 times, so that is why you can take 3 Ke maxima is equal to hc by lambda by 2, because in the second case they said wavelength is lambda by 2, no, minus pi, because light incident over same metal na, so that is why work function does not changes. Okay, now divide second one by first one. So you know this by this Ke cancel now 3, right? So 3 is equal to, okay, so hc by lambda by 2 means 2hc by lambda, right, minus work function, right, by, okay, now first one, you know, hc by lambda minus pi na, so take to other side, you know, 3hc by lambda minus 3 pi na, that is equal to 2hc by lambda minus pi. Okay, so you get hc by lambda na, this if you take to other side, or there 3 pi minus pi na, 2 pi, no, so pi becomes hc by 2 lambda. Now about the given problem, so a light of wavelength you have given 500 nanometers, n means nano, you know, no, so wavelength is 500 nanometers, is incident on a metal, and work function of that metal you have given 2.28 electron volt. You know, electron volt is also one of the unit of energy, right? So you want to find the de Broglie wavelength. Okay, so you know, according to Einstein's photoelectric equation, right, so energy incident, right, hc by lambda. So remember, whenever you want to get energy in EV, you better take this product 12,400, and wavelength must be taken in angstrom, remember. Okay, but over here wavelength is 500 nanometers, so you require one more 10 of angstrom. You know, 1 angstrom equal to 10 power minus 10, so that is why this I am taking it as 5000 angstrom. No, 500 nanometers can also be taken as 5000 angstrom. Okay, so 2 zeros cancelled, you know, 124 by 50. Nothing but 2.48 eV electron volt. So what is the total energy? 2.48 eV. Out of that, 0.28 eV energy for work function na. This is total. And work function is 2.28. So therefore, kinetic energy is remaining na E minus pi. Nothing but 0.2 eV. So whenever you want to find de Broglie wavelength na, instead of using Planck's constant and all, you can take simply 12.27, okay, by root of this kinetic energy 0.2 eV. Then you get wavelength in angstrom. Remember. So when you simplify that, you get nearly around 28 angstrom. Okay. Sorry, 2.8 angstrom. No, 28 angstrom only. So which is equal to, you can take 2.8 into multiple of 10 power minus 9 also. Okay. Actually you get around 2.7. Okay. Now about the given problem. They said the incident energy increased by 20%, then the kinetic energy changes from 0.5 eV to 0.8 eV. So in such case you want to know work function of the metal. Okay. So according to Einstein's photoelectric equation, right, E equal to incident energy is equal to work function plus kinetic energy, or you can write kinetic energy is equal to, okay, total energy minus work function, right? So in the first case, kinetic energy is 0.5 eV na, which is equal to incident energy minus work function. But in the second case, they are saying that energy increase by 20%, means 1.2 na total energy. Same metal, so that is why no change in the work function. So in such case, kinetic energy is 0.8 eV. Okay, now, so when you subtract na, cancel, right? So minus 0.3 eV is equal to, you can take 0.2 E minus, right? So minus cancelled, right? So total energy is equal to 1.5 eV. Okay, so total energy is 1.5 eV. Okay, you can substitute anywhere, you can find work function. Suppose if you are substituting over here, 0.5 eV na equal to 1.5 eV minus work function. So work function will become 1.5 minus 0.5, 1 eV. Okay. So based on this hydrogen spectrum also, in the competitive exams you will be given definitely one question. Okay. So now about wavelength. Okay. So wavelength, z square r, Rydberg constant na, into 1 by n1 square minus 1 by n2 square. So first about last term of Balmer series, that means transition taken to second orbit na, last means infinity, right? So hydrogen spectrum no, so z value is 1 into Rydberg constant, right? 1 by 2 square minus 1 by infinity square. So right, 1 by lambda 1 is equal to Rydberg constant into 1/4, right? So lambda 1 will become 4 by r. Okay. Now in the second case, Lyman series. So transition taken from infinity, because they are saying last line na, so infinity to first one, no? So that is why 1 by lambda 2 becomes Rydberg constant into, okay, so 1 by 1 square minus 1 by infinity square. So this 1 by infinity square value is 0 now. So it is nothing but lambda 2 is equal to 1 by r. Okay, so you want to find the ratio of wavelengths, right? So lambda 1 by lambda 2, right? So lambda 1 is 4 by r now, by 1 by r. Cancel now, you get 4 times. Okay, so the ratio of wavelengths is 4:1. Now about the given problem. So in this problem, first transition is taken from second to third, right? So 1 by wavelength, is equal to Rydberg constant into hydrogen like atoms, Z value taken 1 now into 1 by, so 2, 3, so 2 square minus 1 by 3 square. So which is equal to, you can further simplify, you will get 5r by 36. Right? Now in the second case, wavelength Rydberg constant into transition taken from 3, 4. Usually when electron jumps from higher to lower, then only energy is emitted. No, third, fourth. Equal to 7r by 144. Okay, so when you further simplify lambda 1 by lambda this by this, if you are doing, you get 20 by 7 or cancelled. So wavelength in this case, 20 by 7 into initial wavelength given, lambda. Okay. Now about the given problem. In hydrogen like atom, excitation taken third to second, not orbit. So third excited means N1 taken 4 and N2 taken 3. Second excited state now. So energy, Hc by lambda, which can also be taken as minus 13.6 of 1 by N1 square minus N2 square. So here 4 now. Okay, so when you simplify, you get 13.6 now of 7 by 144. Now in the second case, second excited to first they are saying, right? So Hc by lambda 2 you can take now, which is equal to minus 13.6 of second to first excited states, right? Equal to 13.6 of 5 by 36. Okay, so when you take the ratio of these two, right? Lambda 1 by lambda 2. No, these are all cancelled. You get 7 by 20 by 7, right? Reverse, no? Okay? So based on diodes, semiconductors also, definitely you will be given 2-3 questions in the competitive exams. Now suppose you have given a question, find the diode which is connected in forward bias. So diode is a valve of cathode and anode. No? So whenever diode is connected in forward bias, so definitely current flows. Reverse bias, current does not flows. No? So when does current flow? Only when there is high potential point connected to low potential point, no? Then current flows. How long current flows? Till both attains to same potential. So you have to find the point where it is connected from high to low. Okay? High potential to low potential. Okay? Now you see first case. 0 volts minus 2 volts. Now 0 to minus 2. You know, this is high potential, this is low potential. So there is a possibility to send current. No? So that is why this you can say connected in forward bias. Remember, only when diode connected in forward bias, current flows. If it is connected in reverse bias, current does not flow. Because in case of forward bias, the diode is offering very low resistance. So remember, in order to identify the diode which is connected in forward bias, you have to select a point where it is connected from high to low, but not low to high. Now you see second option, minus 4 to minus 3. So you can say minus 3 greater than minus 4 now. So low potential, high potential. So current does not flow. Now next one, minus 2, 2. So this is also low potential, high potential. So current does not flow. Now in this case 3, 5. So this is also low and high. So that is why current does not flow. Now about the given problem, you have given a circuit and they are saying that this cell is offering negligible resistance. Okay, so you want to find current in this circuit. Flow of current anywhere, it is voltage by resistance. Okay, so whenever this type of problems are given, first we have to find about forward and reverse bias of diodes. So remember, whenever diode is connected in forward bias, it will be considered. Otherwise, it will not be considered. You see here, D2 is in reverse bias because positive to N end, negative to P end. Now, so this is taken as P, N. So positive turn of the battery to P, negative turn of the battery to N. Then it is said to be connected in forward bias. So you can say only D1 is forward biased. Okay, so voltage 5, total resistance you have to find. Only this we are considering 50 and 20 in series now. So that is why current is equal to 5 by total resistance. Current units, ampere. Now ampere is a unit of current. So remember, whenever diode is in reverse, that corresponding resistance and all are not taken. Only one which is connected in forward is only taken, because you want to find current now. So current flows only in case of forward bias. Why? Because diode is offering very low resistance. In case of reverse bias, current does not flow because diode is offering very high resistance. Now about based on diodes also, diodes, gates, transistors, you will be given around 2-3 bits from semiconductors. So easiest way of answering is from logic gates. Okay, so in this problem you have given 2 gates. So whenever gates are given in the circuit, first you must be in a position to identify the gates. Okay, so if you notice, this is one OR gate. Okay, and this one AND gate. So if you know this, it is easy to solve the problem. Okay, OR, addition, and multiplication. No, so AB, no, addition. No, so A plus B, C multiplied with this na is output. A plus B into C gives output. And no, so multiplication operation. Now you have given some cases and you want to get output as 1. Okay, so it is an AND gate. No, so unless the 2 inputs are 1, output cannot be 1. No, but A and B, you can take A1, B0, otherwise B0, A1. But C must be 1, then only there will be output. No? So, AND gate. So that is why both the inputs must be 1, then only there is output. So what is condition of AND gate? Unless the two inputs are strong, there is no output. So that is why C must be 1. So when you look at the option C0, C0, C0. So C is 1 only in this case. But A1 na enough. 1, 0, 1, 1. So output is also 1. Okay. Now about the given problem. In this problem, you have given two logic gates. No? AND gate. Now another AND gate, and you have given a bubble also. Okay. So you know AND gate works under multiplication operation. Okay. So the output of this AND gate is connected to another AND gate along with C. So first you have to write the output y equal to. So first these two, now A into B. Okay. So this is one output and another one is C. AND gate now. So multiply. Bubble. So negation. So A, B into C. Why? Because it is also one AND gate. No? And you know, it is AND gate. So that is why product you are taking. Bubble. That's why negation. So what is your question? When all the three inputs are 0 first, next 1. No? So first case we'll take. Now, when all are 0, 0. 0 into 0 into 0, right? Negation. So you know 0 into 0, 0 na? So you know about AND gate. When both the inputs are 0, output is also 0, right? Into 0. Okay. So negation is 1. No? Because in case of AND gate, you know, both the inputs must be strong. Then only there is output. Now you see second case. Y is equal to. Take all are 1. Okay. So when both the inputs are strong, you know, output is also strong now. So 1 into 1. Negation. So two inputs are strong now. Output is also strong. Negation. 0. That means in the first case 1. Second case 0. So here when all the inputs are 0. Here when all the inputs are equated to 1. Okay. Based on transistor also you will be given one problem. So you know in case of transistor, emitter current is always equal to, remember, base current plus collector current. So this amplification factors alpha and beta you can identify easily. Remember, whenever the value is less than 1, it is alpha. Okay, greater than 1, beta. And you know about alpha. Okay, so alpha is equal to collector current by emitter current, because you know emitter is having maximum current, followed by it next collector, least base. No? So that is why this value will become less than 1 only now. Now, according to this problem, alpha value is given. No? 0.96 equal to collector current by emitter current known in this problem 7.2 milliamp. Okay? So collector current will become this 0.96 into 7.2 milliamps now. So you get around 6.91 milliamps of current. That is collector current. So in this problem, emitter known, collector known. You can find base now. So base current is equal to emitter 7.2 milliamp minus 6.91 milliamp equal to, you know, 0.29 milliamp. So very less current is base. maximum emitter. Now about the given problem. So 10 power 10 electrons are entered in the emitter region in 10 power minus 6 seconds. So you know emitter current equal to Ne by T now. So number of electrons enter into emitter is 10 power 10. Electron charge 1.6 into 10 power minus 19. In how many seconds? 10 power minus 6 seconds. No? So plus 10 minus 19. No? So 1.6 into 10 power minus 9. By 10 power minus 6 na cancelled. No? So 1.6 into 10 power minus 3. Okay? Is milliamps is the total current. No? Emitter current. Now 2% of electrons are lost in the base, they are saying. So current in the base region is 2% now, means 2 by 100 of that 1.6 milliamp. Nothing but you can say 0.02 na into 1.6 milliamp. Therefore collector current will become emitter minus base na, emitter minus base. Okay, so you get 0.98 na into 1.6 milliamps. So you want to find amplification factor beta. So that is beta is always greater than 1 na. So collector by base. Okay, so collector 0.98 na into 1.6 milliamp by base 0.02 na into 1.6 milliamp. Okay, so these two are cancelled. Now points cancelled, so 49. Amplification factor is 49. Okay, now about nuclear physics. So based on this radius of nucleus also you will be given some problems. Okay, so radius of nucleus is equal to R naught into a power 1 by 3, where R naught value is 1.2 Fermi into a power 1 by 3, where A mass number, and remember 1 Fermi equal to 10 power minus 15 meter. All nuclear distances are measured in Fermi. Okay, so ratio of radii, it is constant now. So A1 power 1 by 3 by A2 power 1 by 3. So in this problem, radius of aluminium you have given RAL. Okay. By second one you want to find, that is about tellurium. Okay, equal to A1 mass number of first one 27 na, by second one 125 power 1 by 3. Okay, so 27 you can write 3Q, 125 you can write 5Q, right? So 3 by 5 whole power 3 into 1 by 3. Cancel now. So R2 is equal to 5 by 3 times of radius of aluminium. Now about the given problem, there is one radioactive sample. Okay, its half-life you have given 12.5 hour. Okay, and initial mass of it is given as 256 gram. Okay, so you want to find the time taken by it to get only 1 gram. So 256 grams of a radioactive sample so disintegrated, so that only 1 gram is left. Okay, so the time taken by it you want to find. So in this type of problems, you know, n by n naught, okay, is equal to 1 by 2 power t by t. Okay, so n always denotes about left mass. This is initial mass. Okay, this one you know, half life, and this is the allotted time, we can say. Okay, so here 256 is initial and final is 1, right? So you can take directly 1 by 256. Okay, initial 256, left 1 that is equal to, you know, 1 by 2 power allotted time you want to find, no, half life given as 12.5 hour. Okay, so this 1 by 256 you can also write 1 by 2 power 8 is equal to, you know, 1 by 2 power t by 12.5, right? So you know, whenever bases are equated, powers are also equated now. So 8 is equal to t by 12.5 hours, no? So time taken is 100 hours. That means 256 grams of a radioactive sample takes 100 hours to complete disintegration, so as to left only 1 gram. Now about decay model. So based on alpha decay, beta decay or gamma decay, you will be given one question in the competitive exams. In this problem, there is one element, okay, mass number m, atomic number n. So this emitted alpha particle and 2 negative beta decays. So after the emitting these particles, you want to know the nucleus. Remember, whenever alpha decay takes place, no, so in such cases, remember, number wise 2 subtracted, okay, mass wise 4 subtracted, because you know alpha particle means double positive helium ions, so that is why mass wise 4, number wise 2. Okay, some other element, say y, followed by it they are saying 2 beta decays now. So whenever a beta decay takes place now, then remember mass wise no change, only number wise one added or subtracted, but this is negative beta decay, so that is why number wise one added. Okay, 2 negative beta decays, no, that is why 2 times 1 added, so thereby you know you get some other element, but mass wise no change na, m minus 4 only, number wise cancelled, n left. Okay, so this. Now about the given problem. So helium element, you know, it is formed by 2 neutrons, no? So the binding energy of this helium given as 28 MeV. So you know each neutron having energy 2.2 MeV, no? So energy released is equal to binding energy of helium given as 28 MeV na, minus, you know, 2 neutrons combined together forms helium, no? So 2 times of binding energy of each neutron, 2.2 MeV na, so you get 28 MeV minus 4.4 MeV. Okay? So it is 23.6 MeV. So the energy released in this process is 23.6 MeV. Now about the given problem. There are two radioactive materials X1 and X2 having equal number of nucleons. First decay constant is 5 lambda, next one is lambda. They said after a certain time the ratio of disintegration given as 1 by E. That time you want to find. So according to law of radioactivity, N equal to N0 into E power minus lambda T. Okay? Now about first one. N1 is equal to E power minus 5 lambda T into N0. Second one, N2. Decay constant is lambda na? So E power minus lambda T into N0. Given that both are having same number of nucleons. Okay, now ratio N1 by N2. Okay, so that is equal to E power 5 lambda T na by E power minus lambda T, which is given as 1 by E. No? So this can be taken as E power minus 4 lambda T na, which is equal to E power minus 1. Okay, so whenever bases are equated, powers are also equated. Now, so time taken to get ratio as 1 by E is equal to 1 by 4 lambda. Thank you for watching this video. So I made a number of videos which are very much helpful for all competitive exams like NEET, Mains, Eamcet. So if you want anyone among it, I have given in the description box. Okay, you can watch. Links are given in the description box. You can watch at any time. Thank you.